We're going to look at graphing vertex form of quadratics. So the first thing we'll do is we're going to just take a look at the general form for vertex form, okay? There is an A, there's an H, and there's a K. Now, most of your examples right now, they don't have the A, but all that means is in our examples where we have, and we're going to pull from above here anyways. Let me pull one of the questions here. It says something like this, y equals x squared minus 4. All that means is the A value happens to be 1. Okay, you'll notice there's no bracket here. What that means is in here, this H value is 0, and this negative 4, that's actually the K value. Okay, and most of our examples are A value is 1 here. That's going to make it easier because what we're going to draw is we're actually going to draw this function. This is called the parent function. This is when everything is about its easiest. The vertex is at the origin. Because if I was to expand this, let's say I draw it like this, y is equal to x minus something squared plus something. Well, if I was to simplify back into x squared, that means my h value would be 0, my k value would be 0, and it turns out my a value would also be 1 in this case, okay? So just be aware that these two equations are the exact same. Just this one's far simpler to look at. We're going to make sure we can graph this one here, and then we're going to start implementing h and k and how that helps us graph. So there's a couple steps. First of all, because h, and you and I talked about this, but the x value of the vertex and the y value of the vertex are actually equal to the h and k value of vertex form. And in our case, that happens to be 0 and 0. So that means the origin is where the vertex is. Now, because this equation is x squared, there's a couple ways I can go about this. I can make myself a little table if I like, with all of my x values and then my y values. Okay, let's put this up here. And let's say I wanted to start at 1, 2, negative 3. Oops. I could say negative 3, negative 2, negative 1. This is 0, 1, 2, 3. What we could do is we could input x values. So I could go like this, negative 3, negative 2, negative 1, 0, 1, 2. And then if I get more room, 3 down there. Okay. And what ends up happening is y is technically equal to x squared. That's our equation. So what I would be doing is I'd be plugging this value, negative 3, into here, and then squaring it. So an example of that would look like this. Y is equal to negative 3 squared. Well, it turns out negative 3 squared is 9. Okay, so I can write that down here. And we set up our table. And, oh, I'm not going to be able to get to 9 here, but 1, 2, 3, 4, 5. Oh, this is a bad example. I did not move this far enough. Where are we going to go here? 1, 2, 6, 7, 8, 9. Way up here, one of those points, okay? We'll do another one with the table just to show it. We'll do 3 steps with the table really quickly. Another one would be y is equal to negative 2 squared, which happens to be 4. So in this case, this is another coordinate. What we're doing is we're essentially finding coordinates here. We're plugging in x values, and then we're getting y values. So at negative 2, we get 1, 2, 3, 4. Here's another. And then finally, we can say, well, what about y is equal to an x is negative 1? We plug it in. Y is equal to just 1. There's another coordinate, negative 1 and 1. So what I did there, 1 and 1, here we go. I have it. And I'm going to do a rough estimate curve here. This is the beginning of my parent function parabola. Okay, I did that with a table, as we saw below, but there's actually an easier way to draw the original. I'm going to do it on the right side, and you'll see that we can duplicate it. All you have to do is start at the origin, and however many you go over from the origin, you square that in terms of going up. So if I go over 1, well, 1 squared is 1. I go up 1, okay? Go back to my origin. If I go over 2, 1, 2, well, 2 squared is 4. So I go up 4. 1, 2, 3, 4. There's my coordinate. What if I want to go over 3? Well, 3 squared is 9, and 4 squared would be 16. And that's how many y values to go up. So I'm going to jump up here. And you'll notice you end up with the exact same curve. So instead of making the table, you can either choose to go positive 1 and then square it, or negative 1 and square it. And that will bring you to your y coordinate. So you just start at the vertex. If I go over negative 2 squared is 4. 1, 2, 3, 4. That's my next point. Back to the origin. 1, 2, 3. Well, 3 squared is 9. Gives me up to my next y. So we just square values for quadratics to find out their y coordinates. in reference to how far they'd moved from the origin, okay? That only tells us about this one, x squared. That's because that's where the vertex is. I would repeat this exact same pattern over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16, over 5, up 25, wherever my vertex is. So as long as I can remember this pattern, all h and k do, right here, is they just change where the vertex is. So instead of starting from the origin, maybe the vertex is right over here. Okay, let's say my vertex is way over here. Well, I'd go over 1, up 1. And I would do the same to the left. I'd go, okay, over 1, up 1. Here's another coordinate. So we start. And I go over 2, up 1, 2, 3, 4. And we continue. Over to the left 2, up 4. And we continue, okay? So h and k just tell us where to put our vertex. So let's wheel ourselves back in here. This is one of our questions. And I kind of drew it all funny here because I inputted an a value, an h value, and a k value. I'm going to rewrite it though. Y is equal to x squared minus 4. Okay. Well, what's my vertex? My vertex here is 0 and negative 4. So I'm going to put my graph out here. Turns out the vertex is at 0. So we're still on our y-axis, but we go down 1, 2, 3, 4. Well, if I start from here, same concept as before, go over 1, up 1. Put my coordinate on. Then I go to the left, over 1, up 1. Put my coordinate on, okay? Then I go back to my vertex. Go over 1, 2. 2 squared is 1, 2, 3, 4. So I put it there on the x-axis, okay? Same thing here, back to the vertex. 1, 2 to the left. Negative 2 squared is positive 4. 1, 2, 3, 4. And we put our next one on. Then the same concept from there, we go over 1, 2, 3. 3 would be 9. This one was at 4, 5, 6, 7, 8, 9. Way up here. And symmetrical on the other side, so we end up with our graph. So this is a graph of y is equal to x squared minus 4. So as long as I can find my vertex, which in this case was 0, negative 4, and I can remember my pattern, however far I go over from the vertex, I square that number to go up, I'm set. That's how we graph using our vertex form.